All right, our objective for today, I can solve and graph two variable equations. Yeah, everybody on three. 1, 2, 3. One more time. 1, 2, 3. Yeah, you should be excited. This is already like breaking the old 7th grade. You're shaking off already 7th grade of one variable stuff, and we're moving on to better things. All right. So today we're starting with I'm going to introduce two variable equations. However, today we're going to be looking at something else that we call literal equations. So for the title for your notes, instead of titling it two variable equations, title them literal equations. And as you're doing that, let me just recap and show you the roadway as to where we're at according to the school year. We started at the beginning of the school year. Remember, we started with just numbers. Remember that? We did a lot of stuff with real numbers. We did all addition, subtraction, multiplication, and division. All right. From there, we moved on to expressions. And we did numerical and variable expressions, which were the algebraic expressions. You guys remember that? From there, from the expressions, we also introduced polynomials. And I said, from now on, polynomials are not going to leave. They're always going to be with you. You're going to go to donut and you turn and polynomials. So anyways, from expressions, we said, once we get done with expressions, we did addition, subtraction, and multiplication of polynomials. The only thing that we have not gotten to is what? Division, which we'll get to later on once we get enough practice under our belt with those three. From there, we did a lot of stuff with exponents, also with expressions. Remember that? Exponential expressions, different properties. And from there, finally, we're like, okay, so we're done with all those expressions, and we're moving on to one variable. We started with what? Equations. And we did a bunch of stuff with that. Is that correct? And from there, I said, so once we're done with that, now we're going to one variable inequalities. All right, so basically we're done doing a bunch of stuff with those two things. Well, now that we're done with the easy stuff, yay. Now we're moving on to two variable equations. So, funner stuff. So, two variable equations. That's our concept for today. So, write that in your Frayer model. Now, before I give you the definition, I'm going to have you think a little bit. Here he goes. Think about, let's think back to the definition. Don't say it out loud. Keep it to yourself. Think about the definition for one variable equations. Don't say it out loud. Keep it to yourself. What is the definition for one variable equation? It should be a simple one. All right, talk it over to your neighbor. What would be the definition for one variable? All right. So who has a definition for me? Clarissa? Two expressions that equal to each other and contain one unknown variable. That, it depends if you agree with that. Yeah, that's pretty much solid. So think about that. If that's the definition for one variable equation, think about it. What would be the definition for a two variable equation? Talk it over with your neighbor, please. Right, I heard blah, blah, blah the same, but two variables, right? So write that down, please. Exactly what you said. Mathematical statements where two expressions are equal to each other and contain two unknown variables. Man, you guys are pretty good. Remind me in kindergarten. All right. Copy that, please. Also, I'm going to give you some examples. Write those down, some non-examples. And once you're done copying, I'll go over this according to the definition so we can compare those. Go. All right, here we go. So, according to the definition, it says two variable equations are mathematical statements where two expressions are equal to each other and contain two unknown variables. So let me show you this one. Expression equal to each other, yes. Two unknown variables, yes. Same here, same here, same here, and same here, okay? Now look at the non-examples. Talk with your neighbor, let them know why each one of these is not a two-variable equation. All right. Let's see. The first one, Jacob. Why is this first one not a two-variable equation? Hold on. Okay, go. The what? So this one, because it's not two expressions. Okay. Okay, I'll take that. But look at it again. Specifically, why is, what is another? What is it? Okay, you're getting close. Yes, and one more thing. What is this missing? Bam. Did everybody hear all those three things? Not two expressions, no equal sign, and no two variables. All right? And so we can move on. What is this called, though, Jacob? Expression. Thank you. Pass someone. Daniel Riesco. This one. Why is this not a two-variable equation? Bam. One variable. That is correct. It's my tablet. My tablet. All right. Pass someone. Yes, sir. It's an inequality. Okay. Yes. What kind of inequality? What? I'm sorry? Bam. Two variable inequality. And are we going to get to those? Yes, but not right now. So write yourself like 2 or 3 hashtags here. What makes these two variable equations what they are? Two variable equations. Hashtag what? Volunteer. Hashtag what? Banana. Two variables. Bam. Two variables. Hashtag what? Yes. Equations only. Bam. And one more. Who's got one more? Hashtag. Oh, wow. Hashtag math. Wow. Are you guys hearing this on video? Oh, my goodness. Hashtag math. Wow. Anyways, yes, write your hashtag, please. And let's write 2 steps for today. Only for today, we're going to use 2 steps. Here we go. Write these steps down right underneath. Step number 1, simplify each side of the equation. Start with grouping symbols and combine like terms. Step 2, isolate the variable by using numbers operations. And I'll explain why we're only using the first 2 steps today. Copy that, please. All right, so here we go. So the 2 steps that we're going to use are only the first 2 steps that we've been using with equations and inequalities. Simplify and isolate. And you're saying, why, Mr. Q? Well, I'm going to show you as soon as we get to some examples. But before I do, next up, I want you to just pay attention. I'm going to go over some terminology that I need you guys to understand. We don't need to really focus on it, but I just want to differentiate what we're looking at in regards to the rest of the concept to what we're looking at today. So check this out. First of all, when I say formula, it talks about formulas that have 2 or more variables, such as D equals RT. And by now in science, you guys have been using that formula already. Is that correct? Yes. Distance formula? Yes? Yeah. Yeah, you have been using this. Or rate formula? Yes? Okay, or am I talking crazy over here? I mean, I always talk crazy, but I'm saying it does make sense, right? However, check this out. Whenever they say, for example, this formula, D equals RT. Since D is isolated, that's why we say D is isolated, or we're going to say it's solved for D. Everybody understand that? So whenever I ask you to isolate for a certain variable, it's meaning that you're going to solve for D. Or you're saying, but Mr. Q, but we don't have any numbers. I know. For the purpose of today, we're just looking at formulas that have most of them are only going to have variables. So look at this next one, though. This next term is literal equations. So it's formulas because literal equations have two or more variables. So today's lesson, like I said, I introduced two variable equations. But just for today, we're going to focus on literal equations. What kind of equations? Literal equations. So on the Q side, on your Q column, I want you to write literal equations and write the definition. A literal equation is an equation with two or more variables. A literal equation is an equation with two or more variables. Example, and you're going to write the one that was given right here, which is D equals RT. And then you're going to write solve for D. Is D isolated? Yes. That means it's solve for D. Everybody done? Literal equations. Equations with two or more variables. So, underneath that, I want you to write this. Write two variable versus literal. Underneath where you wrote on the Q side. Write two variables versus literal. So what I want you to do by yourself, I want you to make up an example of a two-variable equation. And then underneath where it says literal, and I want you to make that one into a literal equation. Let me show you an example. 2x equals 5y plus 23. All right. Is that a two-variable equation? Yes. Now I'm going to make it a literal equation. 2x plus 2x equals 5y plus 23 cubed. Why is it a literal equation? Because it has how many variables? It has 3, so it's 2 or more. So this one is a literal equation. So you make up a two variable and then give me a literal. Hurry up, hurry up, hurry up. Everybody done? All right. Share your example with your neighbor, have them copy it, and you copy theirs, please. Do that right now. When they're reading it to you, copy it down and then have them read theirs. All right, we got it? Okay. So with that said, let's get started with some work. Do you have space underneath the steps? At least for one example? Yeah. Underneath, I want you to write example 1. Copy this, please. Example 1A and 1B. So example 1A says, solve x plus y equals 15. And we're going to solve for x. B, solve PQ equals x. And we're going to solve for q. Copy those two, please. All right, here we go. Let's do this one together. Example 1A. I'm going to zoom in. Here it goes. Line down the equal sign. And it says to solve for what? X. So that means we're going to leave x by itself. What's next to x? plus y. So what? How do we get rid of y? Minus y. We're left with x equals negative y plus 15. Some of you probably wrote 15 minus y, which is also correct. But from now on, whenever we're solving for two variable equations, please write the variable first and then the constant. Everybody understand? Yes. If it has a constant. Okay, let's go to 1b. Line down the equal sign. Very similar to what we did. See if you can do that one by yourself. Solve for q. Solve for q. Do yourself first, and then we'll share with your neighbor. Okay. Share with your neighbor, see what you got, please. All right. Let's see. What's happening here between P and Q? Multiplication. So what is the inverse? Divide by P, divide by P. This is a giant 1, so we're left with Q equals X divided by P. Hands if you got that. Okay? Doing okay? Okay, show me with your finger how comfortable you are so far with these. Got some 5s, 3s, 4s. 5, 3s, 4s. Okay, let's do a couple more. Example 1Q. Let's do solve for A. And let's do A, B equals, give me a number. C. That's a number. We just still don't know the value. Bam. Example 1 super Q. A plus B equals C. Let's see how you do with those two. Go. Okay, let's see. Pedro, what'd you get for example 1Q? A equals what? Okay. Let me go over this again. Line down the equal sign. We need to leave A by itself. What operation is happening here, everyone? Multiplication. So what is the inverse of multiplication? Division. So we divide by B, because we need to leave A by itself. So it's A equals C over B. Hands if you got that. Okay. How about example 1 super Q? Orion, what'd you get? Negative B plus C, or somebody wrote C minus B. Is that correct? Hands if you got that. Okay, that is correct. Why? Because this is addition. The inverse is subtracting B from each side. Bless you. And A equals negative B plus C. All right? A little bit better, yes? Okay, let's move on to some funner stuff. Yay! Example 1C. Let's see how you do with that one. Go. Woo! Copy that. All right, let's see. What'd you get for this one, Colton? Oh, so you're going, oh, okay. Divided by 2. 2 1/2. Hands if you got that. Okay, who got something different? Maisha, what'd you get? Hands if you got that. Either one is correct. Yeah, because what is 5 divided by 2? 2 1/2, and you're left with negative B over 2. Everybody see that? Yeah. I would take both of these. So far so good? Yes? Yeah. I prefer probably sunsets in the beach and flying my drone and either one, Raya. Copy this one. Example 1D. Example 1D. Oh, sorry. Wow, be nice. D equals M over V. Wow. So it says solve for V. This is a tricky one. So we need to solve for V. So what shall we do on this one? Let's see. Noah. Multiply M for both sides. Okay. Multiply times M. Multiply times M. So we're left with dm equals 1 over, oh no, which is m squared over v. Ah. Clarissa, what would you do? Multiply v to both sides. Let's see. Yeah, because we need to get rid of the v from the denominator. It needs to be where? On the numerator. So let's see. Multiply v to both sides. Oh, sorry. Multiply v to both sides. There it is. Giant 1. We're left with v d equals m. Am I done?
No.
What do we do at the end? Divide by d. Divide by d. V equals m over d. Hands if you got that. That is correct. Let's do another one of these. Example 2 mega cube. Let's do A equals B over C and solve for C. Let's see how you do.
Yeah.
I'm still writing it. Who got C equals A or B? All right, just checking. Throw that one away. How about B over A? Yay! All right, move on to funner stuff. Copy this one. Copy the formula only. This is the formula for the area of a triangle, and they want us to solve for H. Okay, copy that, please. A equals 1/2 BH, and they want us to solve for H. I'll give you a head start to see what you get. Go. Look up. I'm going to do this in one step. Here we go. Look up. First of all, what is the 2 doing? It's dividing. To get rid of it, I need to do what? Multiply. So this, I'm going to end up with what? 2a. Is that correct? So times 2 times 2. Okay. What is a b doing? So what is the inverse? Divide by b, divide by b. So I end up with 2a over b equals h. Hands if you got that. Okay, good. Yeah? Kind of, sort of, yes? Yes.
Why would you divide? I mean, why would you divide? Yeah, divide by the factor because I want to write
if it's multiplying here? Okay, look up, please. Good question. They said, if this is multiplying, that means on this side I need to divide by 1/2. Is that correct? What happens when we divide by a fraction? And it becomes a reciprocal, right? All right, home play for tonight. Home play for tonight is page 111. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.